All right, so tomorrow we're starting our first lab. And that first lab, you're going to have some different things you're going to have to do on it. When we are looking at making measurements here, we're going to be using a variety of different tools. This is actually the balance that we use, except ours goes to the thousandths place instead of the hundredths. One of the things that you're going to have to do is use what's called a graduated cylinder. Okay. And I have in the back of the room, I have some different pictures of different equipment back there. It looks like I'm lacking this one. This might be something I need to go home and put on there. But I do have pictures in the back of the room to assist you with that. Okay, so this is a graduated cylinder. And when you are recording these, you're going to find something called a meniscus. This is where the water or the liquid, whatever you have in there, is getting attracted to the sides of the container. And we'll talk about why that happens when we get into chapter 12. At any rate, because it has the attraction there, it ends up having this kind of trough that forms. And that trough, we call the bottom of that the meniscus. When you are reading these, you always need to read from the bottom of the meniscus, not the sides. So you wouldn't want to read it here. You want to read it at the bottom of the meniscus. Does that make sense? So when you do that, why are you not letting me draw? There we go. You want to draw kind of a line across and figure out what that is. This is 14, up here is 15. There are 10 divisions in here, so that means that this is 14.1, 14.2, this would be 14.3. And then we always end up going one extra digit beyond that because that's a guess. So is that right on the line? If it is, then it's 14.30. Is it kind of in between a little bit? Maybe it's 13.5. So that last digit right here is always an estimate. Okay. So anybody could guess between, I would say 14.31, 14.30, all of those would be fine. But just 14.3 would not, because you need to estimate that last digit. Like I said, if it's right on the line, then it becomes 14.30. You would get the same credit for 14.30 that somebody else would get for 14.31, because that last digit is just a guess. You're just like, it's in this ballpark, but I can't really tell because I don't have a line marked. Okay. All right. When you're making measurements using a digital device, you do not need to record a guess digit, okay? But you do need to record every digit that shows up on there. For us, with our balances, we're going to have another one out here. So our balances go to the thousandths gram. Because I teach AP Chem, I end up getting ones that go even further because we need that for AP. And I don't trade out balances for one class to another. this is my class set. So these go to the thousandths place. And you just make sure you put them all down. Last year you remember I've talked about that lab final that we do at the end of the year? Okay. Last year, a lot of people just wrote down like 2 digits and it was like good enough. If they would have kept going, they would have probably gotten the right answer. But just by being lazy and not writing them all out, they didn't do their calculations right and they didn't get the points. So, and I figure by the end of the year, if you guys haven't figured out to write everything down, and it's just extra credit on top of your exam anyway, I'm not cutting you any slack at that point. So, all right, let's look at these guys. This is a centimeter ruler. We know for sure that we are between 5 and 6. So we know for sure that this is going to be 5 centimeters. We then need to estimate where this line falls. So is that 5.8 or 5.9? Okay, you might say 9, you may say 8. You are both correct. Okay, so we'll go with 9 because that's what I heard first. Saying 5.5 would not be a valid guess, though. Does that make sense? Saying 5.1 would not be a valid guess. But 5.8, 5.9, I'd take both of those easily. I might even give you 5.7, but that's starting to get a little out there. All right, down here then, we're measuring the same thing, but this time our ruler is divided out further. So this time we know it's 5, we know it's 5.9. It appears to be directly on that line. So how do I denote that it's right on the line? A 0. So you need, what you're doing here is by looking at these measurements, you are telling the person that's reading your measurements what kind of ruler you worked with. Was it divided just as centimeters or was it divided as millimeters? So this is, each one of these ticks is a millimeter in between. So you're telling your reader, hey, I had a better ruler to do my measurement than this guy did. This ruler was not as precise as this one. Remember we talked about precision and accuracy? All right. So here we have a graduated cylinder. We have a measurement here. Then we're dropping a cylinder down inside here. And that water has risen. Just like if you get in a bathtub, the water always rises up. If you pour it too full, you end up water all over the floor. No bueno. Mama gets mad. Daddy might too. Depends on how bad you destroy the room below you. All right. So this guy, remember we're going to measure at the bottom of the meniscus. So we have 10. This is 10.5, 10.6, 10. Does that look like that is right on the line or just a little below? A little below. So it's going to be 10.6. What do you want for your estimated digit? 9. Okay, I'll go with that. So volume of water is going to be 10.69. Now I'm going to come over here and measure this guy. We drop the cylinder in, the water rose up, we're at 14.1 to 14.3, and it looks to be a little above 3. So what will we call that with our estimate? 0.1. Okay. And if it was right on the line, then what would I have written here?
0.
14.30. Now, how do I figure out the volume of just the cylinder?
You do the volume of the water in the cylinder minus the volume of the water.
Okay, so 14.31 minus 10.69. So I ended up with 3.62 milliliters for my answer. I just subtracted this guy. Whoops. How did that happen? Come on. What? Ooh. Sorry, you guys. Here we go. I subtracted this value. Subtracted this value from this value. And I got the 3.62. You're going to end up having to do this in lab later this week, early next week. I can't remember exactly when your lab is, but it's coming up. It's coming up. I believe it's early next week. All right. We do. This is 17. We're measuring the length of this board here. This is 17 point
9.
9.
4.
She's going 4. What if you went 3?
Okay.
Be okay. But you have to have something here. If it was right on the line, that something there would be 0. You have to have that because you're telling your reader how many times this ruler was divided out. If you just wrote down 17.9, that the ruler wouldn't have had any of these black lines on here at all. That's what you're telling your reader when you write that down. That none of these black lines exist. But they do. So therefore, you can't write it like this. You have to write it this way. You're telling your reader how good your instrumentation is, how precise your instrumentation is. All right, uncertainty. For digital devices, uncertainty is measured as the smallest increment using a plus minus symbol. So this device measures to the 100th gram, so the uncertainty is plus or minus 0.001. For an analog device, then, the measured uncertainty is half of the smallest digit. So here, this is marked as 0.1 increments. So half of that would be 0.05. So the volume, 5.12 plus or minus 0.05. I talk about this in these notes for uncertainty. This is the last time you'll hear about it. It's not going to be on a test, not going to be on a quiz. I just introduce it. Why do I introduce it? Because that way, if you end up seeing it later on in another class, you're not like, I've never seen that before. Oh, yeah, Lippy showed you. Graduated markings here are 1 milliliter apart. So the uncertainty of half of that would be 0.5. So volume is 30.6 plus or minus 0.5. All right, we have this guy. This is 4.1, 4.2. This is 4.3 here. So this is going to be 4.2. What? 5. I would say that that's a little bit further down than half.
So 4 or 3?
4. Okay, I'll take 4. And that would be plus or minus half. So it would be plus or minus 0.005. Good. All right. Here we have a Sharpie. I should have dropped a line here for you guys. Okay, so 13 point. Looks like it's just a little on this side of that line. I don't know. You could say it's on the line. Let's say it's on the line. So 13.6. If it's right on the line, what do I have to put down?
0.
0. And that's going to be centimeters. And we're going to go plus or minus. So I do 0.005. We'll just add an extra, 0 and then the 5. Okay?
I'm kind of confused where you're at right now.
Is this not in your packet? I should have taken this out.
It's in like, it's in
5?
Yeah.
Yeah. If you flip to 2.5, it's in there.
Oh, I see.
So. I thought I had a slide on here that said 2.5. Yeah, 2.5. This is the 2.5. And I've talked about that. There was the first answer. for the I do. Good with this slide?
Yes.
Did you get this slide? Give you a second for that.
Please. Thank you.
All right, and then we had one more here. So this one, the bottom of the meniscus is just right below that line. So this is going to be 40 point, we know 5. So it's between 40.5 and 40.6. It's towards the top section there. So what would you say?
9 or 8.
9 or 8, okay? And this is milliliters, and we're going to be plus or minus 0.005. 0.005, right. So you have zeros in these place values for your uncertainty, and then you add a 5 at the end. Easy enough? Again, I'm not going to make you do this throughout the year. I just want you to be exposed to it. The uncertainty. I don't want you to, this part back here, I'm not going to make you do that later on. Did that answer your question? Or were you asking about the 9?
I'm trying to figure out how that's half of a milliliter.
How this is half of a, well, it's not half of a milliliter, it's half of a 100th milliliter.
And then that's 1,000.
Yep, that would be the thousands place.
Sorry, I'm a bit slow.
Honey, it's okay. Don't ask questions. All right. Does that make sense? So your homework's going to be 2.4 and 2.5. But I don't want you working on that right now. I want you, yesterday I gave you a lab in here. Remember? I want you to pull that out. I want to talk about aspects of the lab before we get in there tomorrow. Because tomorrow when we get in, we've got to take attendance and start right away. There is no downtime. We don't have time to talk about the lab. We don't have any of that because we've got to get right into it. Okay? Allie, can you open up that little door next to you? And then turn that handle up, I think. Is it down now? Yeah. Turn it all the way up to the side. Yep, perfect. Thank you. All right. So when we are talking about lab techniques here, we are going to be, we need to, first of all, talk about a little bit of safety. Okay. So where do I have it? Right here. So first of all, you're going to have, if you have hair, longer hair, you need to have that tied back. So make sure that you bring in rubber bands. So it looks like everybody, you two don't have to have your hair tied back. Ray, you two don't. Everybody else does. So you two and you two. Everybody else hair tied back. So Owen, Merrick, Ray, Sophia, your hair's fine. Everybody else is tied back, including mine. Okay? So bring your hair ties. No belly showing. So I know y'all like these croppy toppy things going on right now with the fashion. Got to have a t-shirt on tomorrow. Bring one or else you're going to wear my aprons. You really should, according to your lab safety contract, and if you go to college, that sort of thing, you really should have long pants on. A lot of colleges actually make you have long sleeves. And you should have closed-toed shoes on. So no sandals, flip-flops, that sort of thing. I'd let you get a little bit away with this one. This I'm not. This I'm like set on. It's no negotiating. Okay. If you have a sweatshirt with the ties, you have to tuck those in. If today was a lab day, you would have to take your tie and tuck it into your dress shirt into the side. There is no sitting in lab. Okay. You will stand for all 45 minutes and you will be okay. I promise. I stand for the entire day when I'm doing this, and I'm older than you and I can handle it. So you'll be fine. The reason why we do that, and I've had this happen many, many times. It happens probably once or twice a year throughout the entire year. People will be working with stuff. You know, we have stuff on the ring stands. You can kind of see the ring stands back there. You're not actually using them tomorrow, but stuff will fall off of there. And if you're standing, you jump back. It's just instinct. If you're sitting though, that stuff falls on your lap. You've got second, third degree burns. So there's a reason for it. It's not that I'm trying to torture you or anything like that. It's like a legit reason that I have you do it. Okay. So, questions on that? We'll wear goggles for the first half of the lab where we're using the Bunsen burner. And then the second half of the lab where we're just measuring out salt and water, I'm okay with you taking your goggles off. But when we have open flame, I have to have your goggles on. When we use certain chemicals in here, most chemicals in here, I have to have your goggles off. But this is salt and it's water, so it'll be fine without goggles on for the last half. All right. First thing is a Bunsen burner. So this is a Bunsen burner. How many of you have actually worked with one of these before? All right. So on your lab station, you have these gas jets. You have 4 on yours. I have 2 up here. What you do is you're going to take the tube from the Bunsen burner and it gets plugged in to this gas jet. Okay. The Bunsen burner has a couple different nozzles on it. This one is to let the gas in through this hose. Sometimes people play around with these and they close them all the way. If they close them all the way, then you're not going to get any gas out to be able to start the thing. I tell people not to mess with these. They don't listen. I tell them not to mess with these and just leave them the way they are because I prefer that you adjust your gas at the jet. The reason why I like you to adjust it at the gas jet is so that when you're done, you make sure you turn this off. Because if you leave this on and then unplug your Bunsen burner from the gas jet, now you're letting gas out into the room. And then we got problems. Okay? So that, just try to leave that alone, but if the thing won't light, that's a possibility. Now you guys are second hour, which is the first hour that this lab will run during the day. So there's also a distinct possibility that I forgot to turn the gas on, which we talked about on day 1 in here when you did your scavenger hunt, right? So if that's the case, say, hey, we're not lighting our Bunsen burner. I'll come over. I forgot to turn the gas on. We'll turn it on. Okay. Second part of this, we have this tube coming up here. This tube can be adjusted and turned so that you can let in more oxygen or less oxygen. If this lets in too much, then some of that gas will escape off to the side. You won't end up lighting your Bunsen burner. It's just going to go on and off and on and off and on and off, and you'll never get it lit. So a lot of times adjusting this and turning it all the way down, lighting it, and then getting the right color flame by turning this back helps you. You also have to use matches this year. If you've never lit a match before, that's part of the lesson tomorrow. So you take a match, you hold it between your ring finger and your thumb, and then you're going to apply pressure with your index finger. So I'm applying pressure and I'm sliding it against something rough, which is usually the side of a matchbox. Okay, let's try this again. I knew I was applying pressure because, there we go. I just burned my shirt. It's a brand new shirt. All right, so I'm going to light my match, turn my gas on. I bring my match up from the bottom, and that's the way it looks. Now, if I have not enough oxygen going in, then I'm going to end up with this orange flame. The orange flame, while it may be pretty, will cause you problems, and you're going to find out what those problems are in lab tomorrow. Okay, and then hopefully you won't use the orange flame again. To get this back to a nice pretty blue flame, all I do is turn that barrel and now it's a blue flame. Can you see blue? No. Turn the lights off over there.
Visible.
All of them. Better? You see it now? Right.
A bit better.
Okay, so which way do you turn it to let less oxygen in, and which way do you
Less
turn it to
oxygen looks like clockwise, more oxygen looks like counterclockwise.
counterclockwise, more oxygen?
And you can just turn it and
See which way.
Yeah.
I guess. Okay.
if you get this, you've turned it all the way down and you can't go any further anyway. So if you have that, you've got to go counterclockwise because it won't go the other direction.
Counterclockwise.
So if you're like, that flame is too high, then adjust it at the gas jet and you can make the flame go lower. This barrel should not get hot. I could stand here and hold it all day. Right? If you need to move your Bunsen burner around, and you have to sometimes in lab, grab it by the bottom here and just move it around. The base shouldn't get hot either. But this you should be able to turn all lab long and be fine if you need to. But once you get adjusted, get it the right height, get it the right color, you shouldn't have to touch it again. Okay? Questions about the Bunsen burner? Part of tomorrow is just practicing with it. And then when you're done with it, you're going to turn it off at the gas jet. Right, Allie? So we talked about the color flame, how we adjust that. Let's see here. Electronic balance. This is the way our balances look. There are buttons here. This one down here says power. So that's your first one. That's how you turn the thing on. You need to make sure that you have it plugged in. And you're plugging these in by your waist. Do not unplug my computers to plug in the balances. We have all of these outlets by your waist. That's where they get plugged in at. You will be asked to zero your balance. When you need to zero your balance, you are going to actually hit the tare button, T-A-R-E. Do you remember doing experiments in the past where you had to put something on the balance, you had to measure that thing, then you had to put something in it and measure that thing and then go back and subtract? Okay, this balance does that for you. You're going to have to put a piece of weigh paper on here. Then if you hit tare, this will go back to reading zeros again. So it's going to do that subtraction for you. And then you just add your amount on top here. Do not put anything directly on the pan. This is the pan, unless it's a solid that doesn't leave a residue. So like our lab next week, we have like a metal cylinder. You can put that directly on the pan. It'll be fine. But any kind of powders, any kind of liquids, of course, anything like that, you have to have a barrier between the pan and that item. And like I said, it'll subtract out the mass for you for that, whatever it is. This is an evaporating dish. It's a white dish. It looks like this. And you're going to be using these tongs. These are called crucible tongs. You're going to be using them to hold it over the Bunsen burner. For the crucible tongs, they're almost like a set of scissors. Okay? Put your thumb in one, your ring finger in the other one, and then you can move them back and forth. Make sure that the points, when you're holding it like this, the points are down. So that when you go to pick something up, the points are in the correct location. If you're holding them like this and you try to pick something up, it just gets very awkward. Okay? So points down, and then you'll be able to manipulate it properly. This is an insulating tile. So once you're done heating this, they want you to set that on an insulating tile. This is a scupula, and you're going to have some salt at your table. And you can measure the salt out using the scupula. This is a beaker. Looks like a glass. This is a graduated cylinder. It has graduations on it. These are called graduations, divisions. Okay? Just like school, you have grades. And then you get out, you graduate. Graduated cylinder, beaker. Good? Those are the pieces of equipment that you're going to need tomorrow for lab. Is that? Yep. Questions about lab tomorrow? We had lab groups set up. So let's talk about those and make sure that we have those, okay?